Hi, this is Radek. Welcome to second video from Deep Learning series. This video will focus on basics of image classification using neural networks. In the first part of video, we will look at the theory, and in the second, we will train a custom animal classifier. What exactly is the classifier in connection with neural networks? This is a special type of neural network. This network predicts which predefined class its current input belongs to. In our case, the input is an image. We will immediately show one example. We have a classifier that can distinguish 10 classes from each other. In our case, there are 10 different species of animal: dog, cat, horse, chicken, butterfly, and so on. When we insert the first image to our classifier, we can expect this output. This animal with the highest percentage is our winner. Let's add some theoretical knowledge about the architecture of classification networks, which was not mentioned in the last video. Let's sketch the architecture for a classification neural network. We have the dataset, convolution, pooling, activation, followed by fully connected layers, resulting in our desired prediction. This division into two parts is very important. The first part is called feature extractor. It's used to extract the most essential information from the image. This information is converted into a field of numbers called feature map. Feature extractor is used in all neural networks for image processing. In other words, this part occurs in classifiers, detectors, and segmentation neural networks. The second classification head, specific to the classifier, is most often composed of fully connected layers. This section takes the feature map from the previous section and classifies it. Now we will show what we would need to change to make this classification network a detector. All we have to do in network architecture is to replace the classification with a detection head. This head can locate all the objects we specify in the image based on the feature map. But only in the next video, where we will focus on detectors. Finally, a note on this section. There are many types of feature extractors, classification and detection heads. We can combine them in different ways to be able to create a specific neural network for a particular problem. In practice, we do not have to create our own network architecture from scratch. We have the opportunity to use familiar networks that focus on specific network metrics. Those can be speed, accuracy, memory requirements, type of layers contained in the network, and so on. Here is a list of architectures with different specializations. In the practical part of video, we will use the VGG network. This is one of the first networks that has often been used in technical reports. That was all for today's theory, and we can move on to a practical example. The goal will be to create a neural network that recognizes the 10 species of animal that we mentioned in the theoretical part. What will we need for that? Ideally, a computer with an NVIDIA graphics card for faster network training. Installed Python, ideally using conda, development environments such as PyCharm and Git. You can also download the animal dataset from kaggle.com. All the necessary links can be found in the video description below. For completeness, we will then choose the network architecture, which will be VGG16. A DAM optimization algorithm and cross-entropy loss function. We also have to choose a framework. For today's example, let's choose the PyTorch framework. First, we download the project that was created for this video. After downloading, we will create a development environment using the following command. In the environment file, we have all the necessary Python packages that we need to install. Then we set the created environment in PyCharm. The environment name is PyTorch classifier. To run the demo application, we must first download the pre-trained model using this link. Save it to the pre-trained checkpoint folder and then run the demo file. The input image is displayed and the model prediction is written to the console with the percentage rating. To be able to train our network, we need to prepare a dataset of animal species. We can download from this link and then save the file to the dataset folder. The script preparedataset.py unzips the file and creates two subdatasets for training and validation. Let's take a look at the VGG16 network architecture we will be training. It's divided into a feature extractor and classification head, as we mentioned in the theoretical part. We can experiment with the architecture, add neurons to individual layers or even entire layers. It's important to remember that with each change we have to retrain the network. Let's take a look at the train function, which contains all the important parts for training. You can find these sections in all projects that focus on training image processing networks. The first part is about loading the network model. The next part is the dataset loader, with which we are able to create batches from our dataset images. Next, we will choose the loss function and the optimization algorithm. During training, image batches are inserted into the network. The loss value is calculated from the network output and from the corresponding labels. Finally, it's important to call the backward function to calculate the gradients and the step function to update the network weights. Now, we can start training. During training, it's important that the average loss value decreases. After each epoch, the model is validated. The first model achieved a 16.5 precision percent. This is by 6.5% better than random guesses. This is good news for network training. Once we are satisfied with the network precision, we can interrupt the training. Final model reached 86.5 precision. What can we do with the trained model? For example, we can deploy the model on embedded systems using TensorRT, or transform a PyTorch model to ONNX format, which does network pruning for increased inference speed. Or we can provide trained models on the website using TensorFlow.js. But we will take a look at that in the next videos. And that's all for today. If you like this video and would like to see more, subscribe to my channel. Have a nice day. See ya.